In this video, we will discuss about the motion of rocket. Spaceships are launched in space by rocket. Rocket is essentially a combustion chamber in which solid or liquid fuel is burned. So it is a combustion chamber. Rocket is essentially a combustion chamber in which solid or liquid fuel is burned. So in this combustion chamber, solid or liquid fuel is burned. When the fuel is fired, a hot blast of gas with high speed. So this is the example of how a hot blast of gas with high speed is provided. Suppose the ejection speed is v and this v is constant. This ejection speed is constant and is too high. It's a high speed. It's a high speed. High speed. This is an important point. So when the fuel is fired, a hot blast of gas with high speed is ejected through the nozzle at the rear end of the rocket. So this is the nozzle of the rear end of the rocket. The reaction of the escaping gas provides the necessary thrust. So it provides a thrust. It provides a thrust. Thrust is one kind of force. Thrust is a force. Thrust for the launching and flight of the rocket. Ejection of gas through the nozzle is the action. So this is the action. And the reaction which is created due to this, which compels the rocket to move forward opposite to the gas flow. So as this thrust is occurred downwards, so there is a reaction force for which the rocket is flying to the sky towards the upwards. So this is the whole concept of rocket. So now we have to find an necessary equations for rocket. So first of all, we find out that the ejections of gas is at the rate of v at the v constant speed. So this is a v which denotes the ejections of gas. And suppose in that chamber there is a the rate of change of burning fuel is del M by del T. So this is the rate of change of burning fuel, and the rate of change of burning fuel is del M by del T. So we find out that, and suppose the mass of this rocket is capital M. This capital M denotes only the speed only the mass of this rocket, and del M represent and for this M it actually includes the mass of this steel body rocket with plus the mass of the liquid or solid fuel we put in this chamber. So this is the whole mass of the rocket, and del M by T represent the rate of change of burning fuel. So now as there is a constant speed v, we know according to the Newton's third law, we know force F is, according to Newton's second law, force is the rate of change of momentum. So there, for P, we can write P equals to mv. We know P means the mass and the velocity. The momentum means the product of mass and velocity. So for that we can write, it's not proportional, it will be equal del P by del T. So for there we can write F equals to del of del T into mv. If we put the differential formula of duv, for differential formula of uv, we know ddx of uv equals to u dv by dx plus v du by dx. So we put this formula here and we will get del m by del t into v plus m into del v by del t. As v is constant, so this whole term will be 0, because we know for constant value the differential of constant is 0. So for there we can find out the f equals to del m by del t into v. So this is the thrust. This is the thrust, and we know the thrust force and the force that is the main reason to move our rocket upwards is equal. So if I put this if I put the thrust as small f, if I represent thrust as small f, this thrust as small f, and the reaction force which causes the rocket to move upwards is capital F, then we can write f equals to small f equals to capital of F. So both these forces are equal. So for that we can write capital F equals to del m by del t into v. So this is the one equations for calculating the thrust or the reaction force of when we burn fuel. So now let us calculate the acceleration of the rocket. So give me some time. So the acceleration of rocket, according to the Newton's second law, from the derivation of Newton's second law, we find out that F equals to ma. F equals to ma, and here m means the mass. So here for m we will represent the small m with capital M, because this is the mass of this rocket. So for small m we will represent the small m with capital M, and for force we find out the force equals to del m by del t into v. So for force we will use del m by del t into v. So if we find out the acceleration, then we will get m into, not m, 1 by m into del m by del t into v. This is the formula of acceleration to calculate the acceleration of a rocket. But there is an issue. We doesn't, as the acceleration is acting opposite to the opposite to the g, gravitational force g, or gravity g. So we should minus this g to from our equation. So if we minus this g from our equation, we will get 1 by m del m by del t into v minus g. This is the actual equations for calculating the acceleration of a rocket. So we find out two formula to calculating the motion of rocket. One is the how we can calculate the thrust, and another one is how we can calculate the acceleration of a rocket. Hope you love this video. Please like this video and do subscribe to our channel. Thank you.